Hey you guys, this is Mr. Millings, and in this video we are going to be doing some advanced Boyle's Law calculations. So let's jump right in and take a look at an example problem. In this example problem, it says that 47.3 grams of oxygen gas is pumped into a flexible container and initially exerts a pressure of 1.00 atmospheres. If the volume of the container changes to 5.27 liters, then what is the new pressure in psi of the gas in the container? And it says that we can assume a constant temperature of 273 K. So let's take a look at what's happening here. If we take a look at what's happening here, we have a container, a flexible container. So here's our flexible container. And what we're going to do with this flexible container is we are going to end up pumping in what appears to be 47.3 grams of oxygen gas. Remember, oxygen is diatomic, so it's O2. And so we'll put some gas molecules in here that represent oxygen gas. And so what we know initially about what's in this container is that there's 47.3 grams of oxygen gas. And if we read on, we can see that the pressure inside of this container initially is 1.00 atmospheres. And so what we're asked to figure out is we are asked to figure out what the new pressure, we're asked to calculate what the new pressure is, or P2, in PSI, if the volume of the container changes to 5.27 liters. So what we should probably figure out is the initial volume of this container right here before we can use Boyle's law. And so if you remember, Boyle's law is going to be P1 times V1 equals P2 times V2. So what we need to do is figure out the initial volume of this container first. Once we figure out the initial volume of the container, we can see that the final volume of the container, or V2, is 5.27 liters. So let's figure out the initial volume of the container and of the oxygen in the container. And how can we do that? Well, if we read this question, it tells us that we're pumping in 47.3 grams of oxygen. So if we know the mass of oxygen, right? We know the mass of oxygen here. It tells us that the mass of our O2 is equal to 47.3 grams. Well, we can figure out what the volume is by simply looking up the density of our oxygen gas, right? Because this is happening at 273 K and 1 atmosphere of pressure. If we look on a table of density values, we can use the density formula. Keep in mind that density equals mass divided by volume. We can use the density formula to figure out what the volume of our gas is initially, right? What we can do is multiply both sides by V here. V is going to cancel. This is going to leave us with volume times density equaling mass. If we divide both sides by D, D is going to cancel. And so to get the initial volume of the oxygen gas that's in this container, we're going to have to take the mass of the oxygen gas and divide it by its density. So what is the mass of the oxygen gas? It tells us it's 47.3 grams. And so now if we take a look on a periodic table of density values, like the one that just popped up on the screen in front of you, we can see that the density of oxygen gas is 1.429 times 10 to the negative third grams per milliliter. And so when we put this in our calculator, we're going to end up with 33,100 milliliters. This unit cancels with this, leaving us with milliliters. But if we take a look over here, the volume, or the final volume, is in liters. So let's go ahead and convert this to liters. We know that we need to cancel out milliliters, so we're going to put that at the bottom of our fraction, and we're going to convert to liters, so we'll put that at the top. And there are 1,000 milliliters in 1 liter, so we take this divided by this, and we're going to end up with 33.1 liters. This is going to cancel with this, leaving us with liters, and so this is going to be V1. So initially we can see that the volume of this container is 33 0.1 liters. And what's happening to this container over time? Well, if we take a look at what's happening to this container, we can see that the container is going from 33.1 liters to 5.27 liters. So the container is getting smaller, right? So here's our new container right here, and the gas that is inside here is going to exert a different amount of pressure. And so let's think about this. If we take a look at Boyle's law, what Boyle's law tells us is this. It's the relationship between the pressure and volume of a gas. If the pressure of the gas inside the container is increasing, it's because the volume is decreasing. And if the pressure inside the container is decreasing, it's because the volume is increasing. And so if we take a look, what's happening to our container here? Our container initially was 33.1 liters, right? And if we take a look, our container is getting smaller. It's decreasing, right, to 5.27 liters. So if the volume is going from 33.1 to 5.27, we can see that the pressure inside of this container is going to increase, right? If the volume is decreasing, then the pressure is going to increase. So we should end up with a final answer that is greater than 1.00 atmospheres or 14.69 psi. But if we take a look here, P1 is in atmospheres, P2 needs to be in psi. So let's go ahead and make that conversion before we plug all this stuff into our calculator and formulas. So if we take a look here, P1 is equal to 1.00 atmospheres, but the question wants the final pressure in psi. So we need to convert this to psi. We want to cancel out atmospheres and convert to psi. And we know 1 atmosphere is 14.69 psi. This is going to cancel with this unit here, leaving us with psi. And we'll end up with 14.69 psi. So P1 is 14.69 psi. And so now we're ready to do our calculation. If we take a look, P1 times V1 equals P2 times V2. That's Boyle's law here. And we're asked to figure out the new pressure. So we're asked to solve for P2. So we need to divide both sides by V2 here. V2 is going to cancel from the right hand side. And the formula that we're going to use to solve this problem is P2 equaling P1 times V1 all over V2. And so what is P1? Well, P1 we just figured out is right here, 14.69 psi. What is V1? If we take a look, V1, the initial volume of that container, is 33.1 liters. And what is V2? We just figured out V2, or it tells us rather that V2 is 5.27 liters. And so when we put this in our calculator, we're going to take 14.69 times 33.1, and we're going to divide this by 5.27, and we're going to end up with 92.3. 92.3 what? Well, liters cancels with liters, leaving us with psi, and this is going to be our final answer. And so does this answer make sense? Well, if we take a look at what's happening to the volume, our final volume is approximately 1/6 the value of our initial volume. So according to Boyle's law, if the final volume of the container that this gas is in is about 1/6 the initial volume, then what should happen to the pressure? The pressure should approximately 6 times itself. And so our initial pressure was about 14.69 psi, and this times 6 is very close to this answer right here. So our answer makes sense. All right, so that is going to be an advanced Boyle's law calculation. And keep in mind that Boyle's law states that the pressure and volume of a gas are inversely proportional. If we took a look here, the volume of our container was decreasing, therefore the pressure inside of it increased from 14.69 psi to 92.3 psi. If you like what you see, go ahead and click that little bomb in the bottom right hand corner. That's going to subscribe you to my channel, and feel free to leave any comments or questions in the comment section down below, and I really hope you guys found this helpful.